Let's go through LeetCode 2487. Remove nodes from linked list. So for this question, it gives us a linked list. The head is a the of a head of the linked list. The head node is head, right? Remove every node which has a node has a greater value anywhere to the right side of it. So that means if, for example, those kind of nodes, we need to remove those kind of nodes which on its right, there are some kind of value greater than this value. For example, the 5, right? On its right, there is 13 in the 8. 2 on this right, there is 13 is greater than 2. And then this 3, on its right, there is 8, right? Greater than 3. So as long as there is um, nodes which have value greater than current one, we need to remove this kind of node. And in the end, we left 13.28. So what we're thinking about is that because we want to see on its right whether there is kind of node greater than our current node, right? And if we do not iterate to the next, we'll not see on its right whether there is any greater node or not. So what we think about is whether we can reverse this node first. For example, for example 1, right? We change it to 8, 3, pointing to 13, pointing to 0.5, right? So we'll look at the those kind of linked lists, right? So what we think about it is that we use a left max. So every time we iterate node, trying to see if this number is greater than left max, possibly we set this left max at the beginning to be minus INF or 0, right? Which is great. Means we need to update the left max. And also for this node, we don't need to remove, right? And for this kind of, we'll see, it's smaller. Now the left max become 8, right? For this number, it is smaller than left max. What does this mean? Means we should remove this node, right? So to remove this node, we should have a pre, right? We should have the pre pointing to the next, right? So so um so we remove this. Then we come to here, right? So this one is greater than left max. We just keep this. So we don't need to remove it. And this one, these two are smaller than the left max. So that means we need to have this pointing to next, right? And then this one need to move, right? So this one need to point to the next to the next again until this node iterate to the end, right? So after doing this kind of analysis, we can begin to write code. First thing is that we need to write a reverse. Actually, we remove this, right? So the result will become 8 pointing to 13, right? We remove this and then this. So we should remove again, right? So we can write the reverse linked list as a help function, right? To do this. So first thing is that we can write a reverse private link node or reverse list node. So so what we do is that we put the list node equals to reverse, right? And then after that we do remove first, remove operations, and then return reverse the one which we have the remove, right? The things that normally we are at a dummy node, do the linked list, right? But for this one, we know it will always for the last one, right? Last one, the node, we will never be deleted, because for 8 it will not have any nodes greater than itself on the right. So we can write like this, right? Otherwise, we may need to add some kind of dummy, put the dummy.next equals node, right? Because if in some kind of scenario, we need to remove the last one, for example, the 8, right? We can add a dummy one as a technique. So to do the reverse of linked list, what we need is that we need to have for example, there is linked list here, linked list here, linked list here. We have current pointing to the head, and pre have a none, right? And we are going to use next or temp, right? Temp pointing to here, and what do we need? We use a next pointing to here, right? To get these nodes, and then we can break this point, and let this point to previous one, right? And what we do now is that we move the pre to be our current, and then move our current to this, right? So so we do this kind of operations, and then next pointing to here, right? And this one pointing to pre, and then that pre to be here and the current to be here until current is null, and the pre is pointing to this kind of. What we do is we return this node. So let's begin to write about the reverse function. So what we need is the list node current equals node, pre equals null. So what we do is that while current down equal to none, we have list node next equals current dot next. Right? So we'll have current dot next, current equal to pre. Okay, and the pre equals current, and the current equals next. In the end, return pre. Right? Now this is reversed. So this kind of example one, it becomes 8 pointing to 3 pointing to 13, pointing to 2 pointing to 5, right? So now what we do is that because this were not being removed, right? So otherwise we need to use a dummy here. Then we can have current equals node.next, right? And use another node called pre pointing to this node. And what we do is that for this kind of current, if it is, and also we have left max equals to 8, right? Initial value to be this. So if this value is smaller than left max, what we do is that we have pre pointing to current next, that is remove current, right? And then have our current move to current next, right? So that is this being removed. If this is great, then left max, what we do is that we need if this one is greater than left max, we should update the left max, right? And also we should update the pre to be current, right? Pre to be current, and then our current move to next. So after doing this analysis, we write the remove operations, right? So what we do is that we'll have this node pre equals node, right? Current equals node dot next, and we have int left max equals node dot value. So we'll say while current not equal to none. So if current is greater equal to, right? Greater equal to that means we need to keep this node that is on its left. There is no bigger one. Get next, right? Then we need to keep this. So we'll say left max. Of course, this if it is equal, we don't need to update. But if we add this line, it will not change the value. And pre equals current. And we'll have current equals current dot next, and pre dot next equals current. That is we remove that is if that is whether our pre were moved to the one which is current here, right? If it pre does not move, that means this node is removed, right? So this will be the code, and after that we do another reverse. Current next. Current dot value, right? And we can also convert this one to Python code. We need to have a depth reverse. So we have an with a multiple node, okay, optional list node, and it returns optional list. Okay, so what we do is that we need to have pre and the current equals now. This is now, now, and the node. So what we do is that while current that equal to none, so it is while current. We're going to have next equals current. Also use temp, okay, because next is some kind of keyword current dot next, and we'll have current dot next equals pre, and pre equals current, and current equals temp. Okay, so in the end, return pre, right? So this is the reverse function. So what we need is that we know the how reverse head, right? And then we do the remove this one, which is smaller than the left max, right? So left max equals, let's have that pre current equals node dot value, and the pre equals not pre equals node, right? And the current equals node dot next. Okay. So what we do is while current, so we'll say if current dot value greater equal to left max, right? So we'll have left max equals current dot value. And pre equals current. And we'll say how current the equals current dot next create dot next equals current. And in the end, what we do is that we need to return reverse. No.